Hello everyone, hope you all are doing well, and today we are about to study ideal gas equation. Now ideal gas equation is one of the most commonly used equation in thermal physics, and the equation looks something like this. It says PV is equal to nRT, and we'll see the importance of this equation in going forward with this topic called as kinetic theory of gases and thermodynamic as well. Now let's try to understand this entire equation. Now this equation, which is PV is equal to nRT, is called as ideal gas equation. So any gas which follows this equation is called as an ideal gas. So this equation is called as ideal gas equation, and any gas which follows this equation will be called as ideal gas. Now here P stands for pressure, and this pressure is measured in the SI unit as Newton per meter square. We can also call this as Pascal. V stands for volume, and volume is measured in meter cube. T stands for temperature, and temperature ka unit would be Kelvin. Now many students make a mistake here while putting the value of temperature. We should always make sure that it should always be in Kelvin and never in degree Celsius. So you should never use degree Celsius while you put T in this case, in this equation. Then we come to something called as R, and R is called as universal gas constant, and this value does not change for any particular gas. Now let's come to the value of R, and there is one more term remaining, which is N. Let's see for R right now. So R is called as the universal gas constant, and its value is 8.314 joule per mole Kelvin. So this is the value of universal gas constant, and maybe while studying a course in chemistry you might come across a different value of R, but if you observe very well, then you will find out that this joule would have been in calorie if you have a different value of R here. So in the previous video we have discussed about the conversion factor between joule and calories. So you can just go back to that video and analyze for yourself how this joule can be converted to calories, and when you convert that into calories, this value comes very near to 2 point something. Okay, so you just try to do it. And universal gas constant, that is R, can also be written as Na into Kb. Now in this equation, this all three terms are basically a constants. That is, R is a constant, Na is also a constant, and Kb is also a constant. Here Na is called as the Avogadro's number, and this Avogadro's number ka value is again 6.022 into 10 raised to 23 number of molecules in a mole. So every mole you take, it will any substance, and the number of molecules present in that one mole is always 6.022 10 raised to 23. So this is called as the Avogadro's number. And Kb is the Boltzmann's constant. So Kb is called as Boltzmann's constant, whose value is again fixed, and that value comes out to be equal to 1.38 10 raised to minus 23 joule per Kelvin. So you see, this equation which I've just highlighted in a box, it consists of three constants. and a constant multiplied one constant multiplied by another constant is giving you a third constant. So we will be requiring this when we are finding out the kinetic energies of a gas, or maybe we are finding out the specific heat capacities of a few gases. So this is what R is. This is what or R is all about. So we were on ideal gas equation, and ideal gas equation is PV is equal to nRT. P stands for pressure, V volume, T is temperature, R is universal gas constant. N is still pending. So let's see what N is. So N is called as the number of moles of a gas. Okay, how much gas you have taken, how many number of moles of gas you have taken. And N can be written as N upon Na, or we can also write as M upon M0. Here your N is called as number of molecules in a gas. Na is Avogadro's number, which we have discussed over here. Na is Avogadro's number, 6.022 into 10 to 23 number of molecules in a mole. And M is called as mass of gas, and this is generally written in grams. And M0 is molar mass of the gas, molar mass. Now molar mass of a gas is a fixed value. It can be a signature of a molecule, or it can be a signature of a particular gas. So you see, this is all about ideal gas equation. And yes, we are supposed to know how to find out the molar mass of a particular gas. So gases can be monoatomic, it could be diatomic, molecules can be monodiatomic, polyatomic as well. So let's say, suppose if we are talking about oxygen, and for oxygen, if we are finding out the place of oxygen in a periodic table, it would be 8, and this is because its atomic number is 8. That means the number of protons is 8 in oxygen, and number of protons and number of neutrons are almost equal. I mean, it is equal for lower elements. So number of protons and number of neutrons are equal in oxygen. So you can say that it has 8 protons and 8 neutrons. So this comes out to be 16 nucleons. Okay, nucleons. But oxygen molecule is having 2 atoms. It cannot have a single atom, cannot called as oxygen molecule, because it needs to share electrons. So one atom has 16 nucleons, so 2 atoms will have 32. So what you have is oxygen ka molar mass as 32 grams. 32 grams is for oxygen. Same you can do it for nitrogen as well. Nitrogen is also a diatomic gas like what oxygen is. 2 atoms of oxygen will make 1 molecule. Same way 2 atoms of nitrogen will make 1 molecule. So because nitrogen comes at 7, it will have atomic number as 7. So number of protons are 7. So 7 protons plus 7 neutrons gives 14 nucleons. So nitrogen will have 28 grams of molar mass for nitrogen. Now when this was 14, because there are 2 atoms, So 14 ka double would be 28. So that would be molar mass as 28 grams. Let's do this same calculation for helium. So helium gas, He. Now helium is a monoatomic gas. It's a monoatomic gas. And because this is a monoatomic gas, its single atom is its own molecule. And the place at which helium comes is second in the periodic table. So it has 2 protons and 2 neutrons. So molar mass of helium is 4 grams because it has 2 protons and 2 neutrons. Now if you see for hydrogen, now hydrogen is a diatomic gas. Now if hydrogen is a diatomic gas, hydrogen has a single proton in its it belongs to the first place in the periodic table. So it has only single proton and it does not have any neutron. But because hydrogen is a diatomic gas, its 2 atoms will make 1 molecule of hydrogen. So 1 plus 1, 1 proton plus 1 neutron, 1 proton plus 1 neutron, you will get as 2. So the molar mass for hydrogen is 2, molar mass of helium is 4, molar mass for nitrogen is 28, and for oxygen is 32. Now let's do it for water, H2O. Now in H2O, hydrogen has 4, oh my goodness, 2 grams for hydrogen, H2, and for oxygen it is 16 grams. Make sure that oxygen molecule is O2 molecule. However, in water molecule you have a single oxygen. That's why we do not write 32 for oxygen. We only write 16 for oxygen because we have a single atom of oxygen here. So that comes out to be 18 grams. So 18 grams is the molar mass for water molecule. If you just keep on pulling this analogy, you can get the molar mass of any molecule. Okay, so in this video we are going to wind up at this point, and it was just an introduction of what ideal gas equation is, and we'll be using this ideal gas equation in coming lectures. Just note that you might have real gas equation in your chemistry, depending upon which board you are, which university are you giving exam from. But right now this is what ideal gas equation is, and ideal is just a word, and the gases have under certain conditions behave ideally. Not always gases behave ideally, they behave kind of a real gas, and the real gas, when we discuss about real gas equations, terms of pressure and volumes needs corrections. So maybe in the coming videos we'll be discussing about real gas equation. Thanks for listening to the lecture, and in case if you enjoyed it, please subscribe, and please comment on the topics which you want, any questions, any doubts, any kind of numericals, JE, NEET, anything. Thank you so much.